must be a glow to open.
Okay, this is week number 7 of the winter quarter 2003, and we have the speaker from Singapore today. It's my pleasure to introduce Professor Shankar Krishnan, and also the Professor Lim Mong King will be available for any kind of questions after the main presentation by Professor Krishnan. Professor Krishnan got his PhD degree from University of Rhode Island, I think in the late 70s, if I'm not mistaken. And before joining as a faculty member at Nanyang Technological University in Singapore, he worked at Bechtel, and also he worked at Coulter Electronics, which makes biomedical instrumentation. And he is the director of Biomedical Engineering Research Center at Nanyang Technological University, and also associate professor at the School of Electrical and Electronics Engineering. And also he is the co-director of the Singapore University of Washington Alliance in Biomedical and Bioengineering, which we established last year. So UW and NTU are kind of research partners on the same research project funded from Singapore government. So he will talk about today research and development in bioengineering at the Biomedical Engineering Research Center at NTU in Singapore. And after his presentation, Professor Lim Mong King, who is the Deputy President of the Nanyang Technological University, will be able to answer any questions at the Singapore government and NTU level and the future directions and etc. And it's now my pleasure to introduce Dr. Shankar Krishnan, who will give us a main presentation.
Thank you, Dr. Kim, for your introduction. I'm really pleased to be here. I used to be in Miami, diagonally across, all the way from Seattle, and now I'm in Singapore, which is right close to the equator. The weather is very different from here, bright sunshine, and you're all invited to come and visit us. We have a Biomedical Engineering Research Center at the university, and we are really delighted. We have made an alliance with the University of Washington, and at the outset I'd like to thank Professor Kim and the Department of Bioengineering on the behalf of our university management and myself. That is just a glimpse of our university. That is the present campus that we are in. The university has academic staff of close to 1,000, and we have about 25,000 students. Predominantly in engineering, we have business school and a newly started biological sciences school. We also have communication and education over there. I'll just present the activities at our Biomedical Engineering Research Center more in a broader sense. There are several projects rather than going in depth into any specific project. At Nanyang Technological University, NTU for short, we have several inter-school research centers where there is a lot of interdisciplinary work going on between various different schools of engineering. Biomedical Engineering Research Center is one such center. It was launched in 1997 with participation from the School of Electrical, Electronic Engineering, School of Mechanical and Production Engineering, School of Computer Engineering, and School of Materials Engineering. We started our operations in about 5 years ago. Our vision is to be a center of excellence in biomedical engineering education, research and development, and industrial consultancy, helping to solve challenging problems in biology and medicine. This we share with the University of Washington. Actually, bioengineering being an interdisciplinary field, work closely with the medical practitioners and biologists, The focus of bioengineering in developing new instruments, algorithms, and tools, both on the basic side as well as on the applied side. And certainly we look at this particular aim of proactively leading the way to new ways to heal, new ways to prevent disease, and new ways to improve the lives of the healthy. The objectives of our Biomedical Engineering Research Center to focus on biomedical engineering research within the university itself, to promote collaborative R&D projects with local and overseas universities, healthcare facilities, as well as private industry, and to provide consultancy services and professional services in the region. I just show you this. I'd like to highlight some points. We have representatives from 4 different schools which participate actively in the research activities of the center. This is an interesting point I'd like to bring about, and that number is about 60. We have 60 faculty members. I like to say that our schools of engineering are very large. In fact, many places we have Department of Engineering. In our case, we have a School of Engineering. In fact, School of Mechanical and Production Engineering have about 160 faculty members. I belong to the School of Electrical and Electronic Engineering. We have 270 faculty members. So we have close to 600 PhDs within the campus, so assuming about 10% interested actively in the bioengineering, we have about 60 of them. And here I've taken a modest estimate of about 1. We may be having more than that. In addition to the 60 both master's and PhD students, we have a part-time MSc program. So we have about over 100 students in the graduate level doing research in bioengineering. Okay, that's just a glimpse of our research center. We also have a few labs distributed within the campus where R&D work goes on. In terms of the areas of focus, instrumentation, signal processing, image processing, and telemedicine, this forms a cluster. We have a cluster with biofluids and biomechanics, biomaterials and tissue engineering. We have lasers and robots in medicine and bioinformatics. Okay. It turns out that all these clusters and all these projects, we have great collaboration with persons from different schools of engineering. At the same time, we also have good collaboration with the local physicians. Rather than go over all the projects, I just thought I will just highlight some of the projects, and then there is additional information on our website. In terms of disease focus, okay, heart disease and cancer are like number 1 and number 2 throughout the world. In Singapore, the number 1 is actually cancer, and heart disease number 2. It used to be number 1, but it's number 2 now. So we focus on these diseases, and we also work on diabetes, stroke, and orthopedic diseases. But these are the major ones. In general, faculty, they pursue research of their own interest, but these are the major areas of our research interest. In terms of heart disease, I'd just like to give an example in terms of cardiovascular engineering. There is work going on ECG, signal processing, blood pressure, SaO2, also signal processing, blood flow signal processing, and trying to maybe get the parameters of interest and do some fusion in terms of diagnosis. This is coupled also with the echocardiographic images obtained from ultrasound. Okay. On the other side, there is interest from the microelectronics group looking at blood cell counters, blood gas sensors, heart valves and coronary stents. There's also interest on ventricular assist devices, drug delivery, and laser-induced autofluorescence. Cancer, we focus a lot on colon and esophageal cancer. The presence of upper and lower GI cancer is quite high. In fact, it's probably higher than the average in North America. There is work also on breast cancer, breast and lungs being number 1 for female, number 1 for male. But combined, incidence is quite high. And we also have a group working on prostate cancer using robotic assistance to do TRP. I just list some of the projects that we are doing on instrumentation, intelligent endoscopy instrumentation system. What is done in endoscopy, diagnostic endoscopy, looking at the endoscopic images of the either upper or lower GI, and typically the diagnosis is done after the procedure. The follow-up can be taking place. In terms of getting appointments with the specialists and so on, it is not that easy. So we are trying to develop some screening techniques where some of the intelligence of image processing of endoscopic images can be coupled with the endoscopic instrumentation system. So this will alleviate the load and will also help in early diagnosis. Fiber optic pressure sensor and blood gas instrumentation. So this is just a picture of the endoscopy instrumentation system where we have a lot of intelligence added to the endoscopy. In the fiber optic pressure sensors, we use Vertebrae grading to sense the pressure at various points on a foot pressure sensor. This is of interest to orthopedic surgeons as well as persons treating diabetes, looking at the distribution on this. So there is work done by people in microelectronics jointly with orthopedic surgeons as well as internal physicians. On the blood gas instruments for pH, PO2 and PCO2, okay, that is a standard desktop blood gas analyzer. Singapore has a lot of strength in electronics and microelectronics, so we try to make use of this and re-look into, there has been a lot of interest in ISFED, the ion sensitive field effect transistor sensors. So we make use of that to try and sense this, so the sensors can be really made very small, so the testing can be done in vivo. So this could be very helpful, so we can develop and mount these sensors in a catheter tip. So that is the idea behind it. And then by making them very small, this can have very good applications for emergency room, also dealing with HIV patients and so on. So we'll have low-cost disposable type of sensors for blood gas. On the cardiac instrumentation, there is a lot of interest on the digital hearing aid. One of our colleagues has started a company dealing with this. In terms of post-operative hypertension, I'll show you something here. For patients who go through cardiac surgery, there happens to be some hypertension, and sometimes it's not easily explained why it is. The way to treat it with some drugs, and a lot of techniques which are known today are based on empirical methods. So we have a group of control engineers looking at various control techniques in terms of predictive and adaptive techniques, as opposed to using volume of drug just based on the patient's weight and other details. So this will allow the control to be more efficient. So this is a post-operative hypertension control with predictive and adaptive techniques, making use of some other intelligence like fuzzy systems and so on. In terms of cardiac signal processing, I show you a slide based on what we are doing, as well as the one on fundus image processing. Cardiac signals, well, I just show ECG as an example. There are a lot of conventional techniques which are used, and commercially available instrumentation used in intensive care and CCU are capable of detecting a large percentage of occurrence. However, there is still a small percentage which go undetected. So this becomes, there are cases of so-called false positive and false negative. And we are trying to focus on the false negative cases, which, if they go undetected, may lead to very serious consequences. So since we can make use of some advanced mathematical techniques in terms of nonlinear approaches and so on, we try to detect things such as PVC, trigemini, as well as special incidents or occurrences of ventricular tachycardia, which may be going into ventricular fibrillation or other critical conditions. This is just an example. So this is a different way of looking at them rather than using indices, having like a phase space plot either in 2-dimension or higher dimensions, where we can detect differences. And we also have very different methods of representing them in a 2D, 3D plot. So here the key is to work with cardiologists and come up with some of those parameters which could be very helpful in identifying the conditions which may alert the physician in time. Diabetes, I must tell you one thing, that if a person goes for regular annual physical, a lot of things can be detected. But if that is not a common practice, then people may have to wait for some symptom to occur. So occasionally people go with some vision problems to an ophthalmologist or an optometrist, and they then go and look at the fundus images, and then they find that they indeed have some problems in terms of hemorrhages or the presence of these exudates, which are indicative of diabetes, and this may lead to diabetic retinopathy, and not treated on time, patient, the retina get detached and patient becomes blind. Okay, so he also needs to be treated for diabetes because it has got other areas where it can affect the patient. So our aim here is to look at the retinal images or the fundus images and do automatic diagnosis or detection of the blood vessels as well as other parameters which will help identify the problems as well as quantify what is happening. So if there is progressive deterioration, it can be detected. That is just our setup in the research center. In terms of infrastructure, I would say that we have relatively good infrastructure. fMRI is also of great interest. Something we like to mention that in terms of stroke victims, it was found that they have a different pathway in terms of languages. So for a person who only speaks one language, it is not at all a problem, but for a person may have two languages, bilingual, for example, speaking English and Chinese or any other language, there seems to be different pathways. So our researchers are looking at understanding what is happening with respect to the language interpretation by use of fMRI. Okay. There is also work on image processing techniques for determining the lumen contours, which will give a clear indication of what is happening with respect to lumen. In terms of endoscopic research, we found, looking at the literature, there is very little quantitative information, because normally by the time the endoscopist sees and he finds some problems, depending on the case, he may decide to do either some biopsy or some treatment. If it is with respect to, like, say, polyp, there may be polypectomy done. But very little quantitative data available. So we have an interest group which is trying to come up with some parameters which may be very useful to look at pre- and post-operative conditions and then describe them in a quantitative fashion. Functional electrical stimulation is also of some interest to people in the electrical engineering, looking at developing some very small sensors to do the stimulation. TMJ, this work we are doing jointly with the University of Michigan, where they applied some time frequency analysis techniques to find to characterize some signals from the whales, and then they find the same techniques can be applied for determining the TMJ disorders. In terms of this cancer, there is a type of cancer known as NPC, or nasopharyngeal carcinoma, and surprisingly this is very common only in the people living in the southern China, and this is not present in other parts of the world, except when we did some literature we found in Finland it is also there. So we find nasopharyngeal carcinoma is one area of specific interest to the regional physicians, And once again here, the interest is to try and get 3D reconstructed image and volume values, which will be more useful rather than just the 2D values which are commonly used. Okay. And I'd like to also bring up a point here. So there are some diseases which may be more characteristic and present over there, and this may give rise to possibly understanding some of the basic phenomena. So this is also of interest. Just to show you, there are a lot of students getting involved. Typically, the students in the master's and PhD level are involved, but we also have at the undergraduate level that is known as final year project where they do some research. So some of the final year or senior students get involved in research. We do some work on the ultrasound, and this is on the endoscopic image processing. The university is very supportive of getting the type of instrumentation systems that are necessary to simulate and obtain the data, as opposed to just collecting the data. So we understand the instrumentation related problems, and we also have access to the hardware to go and do whatever is necessary. So wherever possible, we try to have the clinical instrumentation systems available. And we also have, fortunately, being a small place, we have visiting doctors who will come in to help us interpret the data at the same time to help us in maneuvering our research procedures. Telemedicine is of interest. In fact, with the University of Washington, we have a project involving e-medicine and telemedicine. ECG transmission and electromagnetic interference analysis, in fact, ECG signals have been transmitted for a long time. Even 20 years ago, they used to be sent. What is new? What is new is there is a lot of electromagnetic interference which is present today, because the handphones is one example. In Singapore, we have what are known as electronic road pricing systems. So there are some gantries which are present while entering the city, the downtown area, to avoid traffic congestion. And these also have some magnetic elements in them. So it is really interesting to find what is the effect of an ambulance having some signals passing through these. There are several of them. Because occasionally, if it triggers a false alarm and then it then leads to some other condition, this could be a problem. So we look at the electromagnetic interference effects. There is the Singapore General Hospital. We work very closely with the doctors at the hospital. We have set up a telemedicine link, and we try to link up by wireless means, also by web, as well as ATM. So this is from an ambulance to the hospital. Singapore being strategically located in terms of airports as well as the ships coming in, Singapore General Hospital is a trauma center. So they do get signals from all over the region, and they have great interest in trying to understand the signals and interpret them properly. Okay. As you know, in planes right now there is availability of devices for defibrillation, marine services, as well as other wireless techniques. Wireless techniques are improving in their frequency characteristics as well as transmission characteristics. At our university, we have a group looking at satellites, particularly the LEO satellites, the low Earth orbit satellites. So we have a center which is actually building these micro satellites. We have access to sending information to them, and we try to use that as in addition to the geostationary satellite. So when we may look at some screening programs, for example, for mammography, where we have 20,000 data sets, image sets, where the information will be very large, then it may be possible to send it over through satellite link elsewhere for consultation purposes and so on. So we are also looking at satellite for transmission purposes. So there is some ongoing work in that. In terms of biomechanics, there is a big group looking at cervical spinal implant, quantitative 3D anatomy of human vertebra. And I just show you something of interest here. A lot of published data, typically from the medical schools, correspond to Caucasian data. Okay. It turns out the frame, the structure, and the inter-spacing relationship, the geometric relationship found by the orthopedic surgeons slightly are different for the Asian population. And Asian population may be more than a third of the world population. So if you use the surgical instruments and devices to treat something, and then you use a patient who is different, then it may not be optimal. So we are looking at those relationships, and this may be a good feedback to have better design of instrumentation system. At the same time, this will also help understanding the stress distribution and other problems within the spine. So there is a good material testing laboratory where we can do measurements and testing and so on. Okay. Let's proceed to biofluids. There's a group looking at heart valves. So there are two types of valves. One is the valve which is a bileaflet valve, okay, so made of pyrolytic carbon. Here we have a collaborator from University of Miami. We are looking at actually fabricating these valves and testing them. We have access to the high-performance computing lab, so doing some fancy finite element analysis and trying to actually build them and do animal testing and further go on to clinical trials. Now it's at the animal testing stage. In addition to this, there is another approach of using the pericardium to make the valves, and the advantage of using the pericardium is that you solve the problems pertaining to immunology. So use the patient's own pericardium and then try to make the valve. By doing this, it puts a little extra strain on the surgeon because you need to make the valve right on the operating table. So the engineer's role is to come up with some very interesting type of molds so they will be able to make the valves right in the operating room. So this is done again in conjunction with the cardiac surgeon here. There is work going on in biofluids in terms of coronary stents and aneurysm models. There's also interest in doing LVAD, or left ventricular assist device. We are trying to look at some very good pumps and some motors for the left ventricular assist devices. There has been a lot of interest on the CFD studies, and I'm pleased to announce that some of our students have got awards in CFD for this cardiovascular work in the region. There is also quite a bit of work in the biomaterials and tissue engineering area, particularly in terms of thermal spraying, functionally graded bioceramic materials, and hydroxyapatite coatings, and so on. Yeah, we work on polymers, also microspheres for drug delivery, hydroxyapatite for bone regeneration, and hip replacement bioceramics. Tissue engineering, this I'll talk a little bit later. This is an area that we are collaborating with the University of Washington. Lasers, there is a big growth in the photonics area. So lasers are used for at least two applications at our university. One is looking at cardiac output. Of course, cardiac output by using laser techniques have been around for some time, but it's still difficult to estimate the exact area, particularly when you're looking at the coronary vessels. Although you may be able to get the velocity, but the velocity profile to be obtained in small vessels not so easy. There is work going on laser-induced autofluorescence for looking at the arterial plaques. Since automation is also of great interest in Singapore, there is this group working on medical robotics. A couple of applications. One is on using robotic drives, which are both electrically and pneumatically powered in terms of a colonoscope. This Eurobot is for TURP operations, coupled with ultrasound guidance. there is the flexible endoscope for gastrointestinal surgery. So here we are working with the gastrointestinal surgeon from Singapore General Hospital as well as National University Hospital. As you know, bioinformatics has gained a lot of popularity all over the world. We work together with a couple of other research groups within the university and also with the National Cancer Center. I know there is a lot of work in genetic area going on over here. So we do a lot of mathematical modeling and development of algorithms and software used for clinical trial. In terms of our facility, we have this Biomedical Engineering Center centrally located, so it is accessible by members of various schools and researchers. That is the main facility, but cardiovascular lab, but there is a lot of cardiovascular engineering research going on, as well as computer integrated medical intervention lab. These are two other labs. There is a tissue engineering lab separately located, medical image processing and instrumentation lab in the electrical engineering school, and also photonics lab in two schools, electrical engineering as well as mechanical engineering school. This is the Institute of Education. There are labs in the Institute of Education. And as any other university, we also try to optimize our resources. These are other research centers. This Center for Signal Processing, Robotic Research Center, Center for Graphics and Imaging, Advanced Material Research Center, Network Technology Research Center, Microelectronics Center, and so on. So we try to avoid duplication of work, and wherever possible, bioengineering itself is application of techniques and solutions obtained in different disciplines. So we try to make use of that principle and try to make use of the researchers who are available right on campus. In terms of our research partners, we work with all the hospitals, Singapore General Hospital being very large, the 1,800-bed hospital. National University Hospital has a medical school and it's about 800-bed hospital. Then we have Tan Tock Seng and other hospitals. We have these tertiary care centers, heart center, cancer center, eye center, and so on. So we work closely with them. With the Singapore General Hospital, we have a memorandum of understanding, and we have about 35 collaborative projects. And that, I think, is a big plus because we are able to get active participation by the clinicians. So overseas collaborating institution, I have put SUBA at the top of the list, and we are really very happy, and it is actually a true thing because it is a very big collaboration. And we are indeed very proud, and this collaboration didn't take place just overnight. I think with Professor Lim's initiation of this brainchild, we came and had several meetings with Professor Youngmin Kim, the Dean of Engineering, the Provost, Lee Huntsman, and with researchers from our side. We actually worked on it for over 2 years to reach the collaboration. We also have individual collaboration of various faculty members. I just put some representative examples. So I just show you a few slides. This happened in July. So this is actually there was lot of sound and so on, but because the number of slides were too big, I took off everything and just put on 13th of May. With Mr. Filipio, who is the chairman of this Agency for Science and Technology and Research. Okay. This signing contract took place. The executive director, Professor Louis Lim of Biomedical Research Council, and our president at NTU and President McCormick of University of Washington. Okay. These are the research initiatives. One is engineered biomaterials and tissue engineering with an additional molecular bioengineering and nanoanalytics, in addition to the distributed diagnosis and home health care, which I'm sure many of you are aware, fits in or blends in very well with the theme of UW's bioengineering initiatives. Okay. So we get involved in research, getting output as patents and hopefully industrial startups and so on. And we are really delighted to have Professor Kim oversee the operations over here. Sandy Chien from our side and Professor Ratner from University of Washington work on tissue engineering. And the theme here is to come up with tissue engineered esophagus. And then this is like a niche area which has been looked at, and very few people are, there are a lot of people working in various areas, cardiac and other sections. very few are looking at esophagus. And as I mentioned before, esophageal cancer is indeed a big problem. Okay, so this we hope will come up with some solutions and which will really have some significant answers. Okay, there is also interest in biomolecular engineering, nanoanalytics, to develop nanoanalytical technologies for complex molecular dynamics. Okay. That is the group of people. We have quite a few from NTU. These are all the faculty members from there, and then you may recognize the names here. These are from University of Washington. The second initiative is distributed diagnosis and home health care. It has got three very significant parts. One is a home ultrasound unit. Okay, this is actually an enhancement or development of University of Washington's strength in ultrasound, plus our own interest in image processing and our expertise in microelectronics and so on. So we are working jointly in developing home ultrasound. We have another one with Professor Paul Yeager on immunoassay techniques. We are trying to develop some new methods to come up very efficiently detecting some analytes of interest which will help in future patients from home. And as you know, people are living longer, so the expectation of getting the results very quickly in a timely manner is increasing. So if we look at some paradigms today, they don't exist because this is something new. You know, people are trying to get treated, and the expectation level is increasing, and the threshold for suffering is decreasing. So consequently, I think this distributed diagnosis, which will have at the core an e-medicine or telemedicine aspect, will really make a big impact. The PIs for this are Jin from our side and Professor Paul Yeager from University of Washington. We have a big team of about 18 faculty members working closely with some doctors there. It also shows some slides of some people who visited us. I try to extract only few. This is something you may recognize from your medical school. They were looking at something we were working on. This is Dr. Chan Kapluk. We are trying to show some cardiovascular work. In fact, this particular work, we are happy we got into the IEEE Congress at the finalist stage at the student paper competition. Okay. These are some of UW faculty visiting our center. This is our president, the past president, Dr. Chamtaw Soon, speaking at the A-Star NTU UW collaboration agreement signing ceremony. This is Professor Louis Lim from the Biomedical Research Council, and this is your past president, ex-president, President McCarthy. Yeah, both are past president, I should say. It's a lucky thing they signed. Okay, so here you can see Professor Lim Wong King, who initiated this. I was just telling him, we started working on this kind of theme about 4 years ago, and we worked very hard, and we are very happy that we came to this realization, and I really feel very happy and proud. Okay. This is Mr. Philip Yo, who I understand visited University of Washington. He is the chairman of A-Star, which is like National Science Foundation, and he's also the co-chairman for Economic Development Board in Singapore. Okay. Okay. This is the team which includes, I think you recognize all these. This is Jin and Sandy from our side. Okay. So Professor Rad, Mr. We have to do some image processing next time. We can do elevate his height. I apologize. Okay. I will like to say that we have a collaboration with Singapore General Hospital. So just for the hospital doctors to understand what we are doing, and also for our own faculty members to understand, we have an annual symposium. In fact, we have had 5. And I'm very pleased to announce that we are going to have the 6th one, which is going to be combined with the University of Washington. And this will be this has all been a local level. So the 6th one, which will be November 26th to 28th in Singapore. All of you are invited, by the way. So will be jointly with the University of Washington and also the other university. And we do have distinguished researchers visiting time to time. And I think I picked mainly from US, but there are also people from Germany, and you may recognize this name and I guess this name. In fact, Professor Ratner was with us in January, and he gave 3 seminars very well attended. And you know, we also, Professor Kim has given a seminar, and it's very much like this, and except there were like 250 people who all enjoyed doing. Yeah, oh, Professor, yeah, of course. I think he gave seminar, and he's also, you know, I saw him very recently in Singapore. Okay, we visited the team here in December, just a couple of our other colleagues. Okay, then also look at this was on the e-medicine project. We actually visited Professor Kim's lab. We are very young. You know, University of Washington has great reputation in bioengineering. We are very young. We just started recently, and we try to do our best. We have, you know, we have reached, we have done something. We have received some international conference, some minor awards, and we are working hard, and we are very pleased. We have made this collaboration with the University of Washington. We hope that it will help us get to higher levels. As most universities, we are also involved in continuing education. Our research strategy is to look at niche areas, high incidence diseases, regional application, physicians' interest, availability of resources, engineering expertise, and of course also commercialization potential. Long-term goals of our center to concentrate on fundamental and applied research in niche areas, collaborate with potential industrial partners, and to provide biomedical engineering consultation in the region. In fact, I would say that in the region we have one of, you know, we have a very large critical mass to do the research in specific chosen areas. I try to put all parts of the body, so we are striving towards reaching excellence. I just, before closing, show you the new Techno Plaza, which is also the brainchild of Professor Lim Wong King. This, I don't know if you'd like to add a couple of sentences about this, but we are going to be moving into this is a brand new building, that $30 million or so, there's the facility, there is the infrastructure, this is going to be ready. In fact, tomorrow there's going to be an inspection walk-in. Next month we'll be moving to this, and the 6th floor over here, we have a separate area for Singapore, University of Washington Alliance in bioengineering. So quite a large, about 12,000 square feet area, and will allow about 60 researchers to be at the same level. And down here, this is all interdisciplinary research centers, and we have a bioengineering corridor on the 6th floor. Okay, I just like to thank on behalf of Professor Lim and our center, and I'd like to express our thanks to UW Bioengineering Department and to all of you. Thank you very much.
Okay, we have time for questions. Yeah, stay.
Oh, okay.
Questions? Yes.
I was wondering if you could elaborate more on the work being done in the area of functional electrical stimulation at Nanyang.
Yeah, I'm not personally involved in that, but the interest is, you know, trying to model neural stimulation by placing multiple electrodes as opposed to a single electrode, and have the distribution. You know, there is a group in Finland that you may be aware of. You know, they are collaborating with us in this particular project. Yeah, yeah. So the area of focus is signal processing, actually developing the sensors and looking at the distribution and how by stimulating at different levels from multiple electrodes, how an action potential can be generated. Okay. So one group is looking at that, other group is trying to model, you know, mathematical equations to do the simulation. And we have good microelectronics fabricating facilities. So we are actually in the stage of fabricating the electrodes. Once this is done, then we will go into animal experiments. So it is right in the initial stages of that. And if you are familiar with the group in Finland, they are the ones we are collaborating with. And we found not that many are in the FES area.
Is the focus then on targeting hemiplegia or paraplegia?
Paraplegics, mainly paraplegics, yeah. And the idea again is, right now the success rate is not very high. So if we have different methods of stimulation, maybe, people are always looking at giving one signal and see how it goes. So try to have multiple electrodes, and if we can, with the nanotechnology, making many electrodes is not difficult. And you try to give signals of different waveforms. Computation is very inexpensive and very fast today. So we can try to do that. We may be able to understand some physiological mechanisms better and what is happening at the biochemical level. Then we'll leave it to the biochemists to solve the problem. We are electricians.
Okay, can I ask a question to Professor Lim on Singapore's kind of drive in life science and how NTU is responding to the challenge?
Well, first of all, I'd like to express how pleased am I for NTU to be in collaboration with University of Washington on the SHUA project, because this is a big project, and I'm sure that with two universities working closely together, we'll be able to create significant impact on bioengineering. Well, NTU is a relatively young university. Our strength is in technology. Though we do have business school and other discipline. And we have been starting to get into bioengineering about 5-6 years ago, and we are now in full swing into this very exciting area. We have set up this center in biomedical engineering, which is just a starting point, and then we are now involved in a SUA. We have realized the importance of life sciences and the challenges ahead, and last year NTU set up a school of biological science. We didn't have science actually. We started just focusing on engineering, and we realized the importance of science, and we started the school of biological science last year. We are going to set out a new school in physical science so that we have a college of sciences, and we hopefully, with science and technology, we will be able to make a significant breakthrough into bio-related area. As on Singapore, Singapore is a young country. We have been very successful in attracting multinational to Singapore to do the manufacturing. And I think with the China opening up, with the relocation of manufacturing to China now is the world manufacturing base, we have to move up the technology ladder. And Singapore government has realized the importance of life sciences and has been putting in a lot of effort in promoting life science since 2 years ago. The first thing the government would do is to realign all the research institutes that are related to life sciences into a hub, what we call Biopolis. The government is investing $500 million in building a big hub called Biopolis, which will be ready in about
July.
Yeah, probably half a year from now. With key research institutes like bioinformatics, bioengineering, molecular cell biology, genome institutes, all this in one location, close to 2 universities. So we have the National University of Singapore and the Nanyang, and we'll be working very closely together. Some of these institutes are new. For example, the Bioinformatics Institute will be new, and there is a new institute going to be set up, which is the IBN, Institute of Bioengineering and Nanotechnology. And of course, the Genome Institute of Singapore is also quite recent. So all those are new recent effort in positioning Singapore into the future. So I think that is what I can say about how we gear up to be more into life sciences. And the NTU, as this is taking off, we are, in fact, we haven't announced, but I can say it here, but we're not in Singapore yet. We are going to make announcement to the press saying that this July coming student intake, we will be offering a bachelor degree in bioengineering.
And size, much bigger than ours.
100. First batch of students will be about 100. How many are you taking?
We are taking about 30 now, and we will go up to 60.
I see. But ours engineering is big, so but 100 compared to other electrical is really small. Our electrical students is about 100,000.
Yeah, we graduate undergraduate 1,200 every year. And all are employed, or at least 80% within the first 6 months of graduation.
And also, I would like to take this opportunity to kind of let you know that there are a lot of the exchange opportunity for graduate students and undergraduate students, both way. NTU students coming to UW and UW students going there. In the beginning, mainly on research, but we are, like today, exploring on expanding that into education as well. And also, those students who are finishing a PhD, and if you want to sample what a faculty member life is like in Singapore, I'm sure NTU will be open to 2 to 3 years of the assistant professorship there, and teaching and research. Facilities there are, as you saw, very good. And would you like to add to?
Yeah, no, I think I have also spent a few years in U.S. and the experience has been really unique. For example, we have the opportunity to teach 800 to 1,000 students at one shot. So, but the advantage of that is afterwards you go to a conference, there are 200, it looks like 1/4 the class size. But having said that, in a serious mode, I like to say that because of the number, it is possible to pick and select people who are truly interested. And then I think, as Professor Kim said, we would welcome the interest from you to come over and visit, either on short-term, long-term teaching or student, very good ways to learn there. I think it's really a unique place. You should come and visit. I think then you will really appreciate it. And we have the international conference. You can even submit the paper, and I hope Professor Paul Yeager will be on the review committee. I hope he approves it.
Okay, any final question? Paul, would you like to make a comment? No.
I say that we've had a lot of fun in the last couple of years putting this together, and we've been up and running for several months, and we're just beginning to see some of the first fruits of our labors coming from the system. I'm certainly looking forward to many years of exciting interactions between the universities. I'm looking forward to accompanying some of my students over to Singapore in the near future.
Okay, thank you very much. Krishna.